This is the solution video for the coordinate geometry revision worksheet. So in my first question, I want to find the equation of a line through a point, and which also goes through the point that divides a line segment in a ratio. So I have my first point minus 3, 2. I'll just put that on the back burner for a minute. And I'm going to look at the points minus 6, 2 and minus 3, minus 4 and see can I find the point on that line segment that I'm going to use in the equation. To get started in that, I am drawing a line segment that starts at minus 6, 2 and goes to minus 3, minus 4. I want to find this point partway along it. So I've written down the full translation to get from the start to the end of the line segment. And now I'm looking at my ratio. So it's 1:2, which means that the point that I want to find is 1/3 of the way along that line segment. So I'm going to take my translation and just get 1/3 of it. So I'm going to use +1 minus 2 as my translation instead. And that's going to identify this point here. And that's going to give me the point minus 5, 0. Which I will use with the point minus 3, 2 to find the equation of a line. First, I'll get the slope, and that's 1. And then I'll get my equation using the slope that I just found and either of the points. I'm going to use the point minus 5, 0. And then I'll tidy it up to get y equals 1x plus 5. That's part A completed. Part B refers to the same line still. They're still calling it the line L. And they want to find where this line cuts the x and y axes. Remember that generally with lines, if you want to find where they cut the axes, you can use y equals 0 for the x-axis and solve for x, and x equals 0 for the y-axis. But actually in this question, they've given me a good bit of information. So I actually know that the point minus 5, 0 is on the line L because I used it to make the equation. And that point is on the x-axis, so that's actually the x-intercept for the line L. And I can use my equation up here to get the y-intercept by just looking at the constant at the end. So I get 0, 5 for my y-axis point. Now I want to find the area of the triangle created by the line and the axes. So I'm going to sketch that first. So I've got my x and y axes, and when I draw my line, I can see my triangle clearly. To find the area, since it is, of course, a right angle triangle, the easiest way to do it is just get the base and the perpendicular height. And the height is 5 and the base is also 5. Don't forget we take the positive version of the value because we're talking about distance. So I'm using half the base times the perpendicular height, and I get 12.5 units squared. Part C, once again, relates to the topics that were covered in Part A and Part B. I've got the same point minus 3, 2. I've got a line going through it. It creates an area the same as the area in Part B, and I want to find the equation of this other line. Again, a sketch isn't a bad plan. Notice that they're saying in the question that M and C are positive constants. So this tells me two things. If M is positive, the line is sloping up. And if C is positive, then my y-intercept is a positive value. When I put this information together visually, I can see that I'm going to have a line that looks quite like my previous line. It's going to be on the left of the y-axis, sloping up, going through the y-axis at a positive point. And of course, it's going through this point minus 3, 2. I want to find the equation of the line. And the only thing that I don't know is the slope. I do know, of course, that the area here is the same as it was in Part B. And if I'm talking about area, it might be useful again because I'm still looking at a right angle triangle to know what the base and the height are. And in order to figure those out, I need to have something for the x and y intercepts. So I'm going to start this off by trying to make as sensible an equation as I possibly can with the limited information that I have. So I've got a line, minus 3, 2 is on it. I don't know the slope. I'm going to call the slope m. And when I fill this information in, I'm going to do something that looks a bit like the equation of my line. I'm going to tidy that up a little bit. So I've got y minus 2 equals mx plus 3m. I could do a bit more rearranging with this if I wanted to, but actually I'm not going to bother because what I'm going to do with this next is I'm going to try and find the x-axis and y-axis intercepts by just doing what I had suggested in Part B, which was to let y equals 0 to find the x-axis and x equals 0 to find the y-axis. So for the x-axis, I'm going to have 0 minus 2 equals mx plus 3m, and I'm going to get the x by itself. So, okay, so now I know that the x-intercept is minus 3m minus 2 over m0. That's that point just there. And I'll do something similar to find the y-intercept. And that's going to be y equals 3m plus 2. So this point here is 0, 3m plus 2. Now, the area of this triangle is 12.5 units squared. I know that because it's the same as the area of the triangle in Part B. And I know that I previously used base and height to figure out area. Now, remember, the base and the height have to be positives. I can see from my diagram that this distance is going to be 3m plus 2. I can take that directly from the point because I can see that I'm in the positive position on the y-axis. Over here though, this point, which is at minus 3m minus 2 over m, that's clearly a negative point. So if I want the positive distance, I'll just times this guy by minus 1 to figure out what the base of the triangle is. So I'm calling that 3m plus 2 over m. So now I've got half the base times the perpendicular height equals 12.5, and I'm going to try and solve this out to find m. It looks like it's going to turn into a quadratic. I'm going to bring the 2 and the m up across and multiply them by 12.5. And tidying this up, I'm going to get the quadratic as predicted. So that needs to be equals to 0, of course. And I'm going to factorise this and solve. So we're getting two solutions for m, 4 over 9 and 1. And they're only asking me to get the equation of one line. Okay, so let's just notice that if we go all the way back to part A, the line that has an area of 12.5, or that creates an area of 12.5 with the x and y axis, was actually the line that we had from part A, and that had a slope of 1. So when we're getting a solution down here of 1, that's just referring back to that original line. So really what I want to work with is this m equals 4 over 9. So I'm going to take that and sub it back into that equation of the line, or I could even go back a step if I wanted and say y minus 2 equals 4 over 9 bracket x plus 3. That's just the expanded version of that. And then all that's left to do is just tidy this up as the equation of the line. And notice in the question that they've asked me to write it as y equals mx plus c, so I'll make sure to do that as well. So my final solution there is y equals 4 over 9x plus 10 over 3. Again, just referring back to the original question, they had talked about the m and c being positive constants. So we're just going to have a glance at that. Yeah, my slope, m, and my constant c are positive. So I'm happy that I've answered the question in the format that they wish.